The Soldier's Reasonable Request. A famous story involves a soldier who rescues his king in battle. The king grants him any prize within reason from the riches of the kingdom. The soldier asks for a chessboard with a single kernel of wheat on the first square, 2 kernels of wheat on the second square, then 4, then 8, and so on for all 64 squares on the chessboard. The king decides that the request is reasonable. Example problem 2 is based on this story. It says, according to the story, on the preceding page, or above, how many total kernels of wheat did the soldier request? We will be using a geometric series to find the answer. I feel that a good way to start a problem like this is to begin generating the series. So the first square had a single kernel of wheat. So 1 will be our first term in the series. The second square had 2 kernels. The third square, 4, and so on. We'll go all the way through 64 squares. So all the way through, let's say, a sub 64. Recall from the previous video of this same section, we need to know 3 things. We need to know our first term. We need to know our common ratio, which is easily derived at this point. And we need to know the number of terms. Knowing these 3 things, we plug them into our sum formula, substituting in our values, doing some simplification and using a calculator, which will provide us with scientific notation. We find the negative of 1.845 times 10 to the 19th power over negative 1. Those negatives, of course, cancel out for us. And we are left with the sum, or in this case the number of kernels on the chessboard, being 1.845 times 10 to the 19th power. That may not seem like a lot at first, but consider what that means. Our decimal point will move to the right 19 places. So that will be, well, 18 places left, 17, 16. So we'll have 1, 8, 4, 5, and 16 zeros. Insert commas as appropriate. And that is a lot of kernels of wheat. You may almost say this valiant soldier who rescued his king then swindled his king out of probably more kernels of wheat than, I don't know, than exist on Earth. And here's a chance to show that you have got it. To save money for a vacation, you set aside $100. For each month thereafter, you plan to set aside 10% more than the previous month. How much money will you save in 12 months? Work carefully and make your selection from the choices below. And the rest of the story. A bushel of wheat contains about 1 million kernels. The total U.S. output of wheat in a recent year was just over 2.1 billion bushels. At that rate, it would take the United States about 8,786 years to produce enough wheat to satisfy the soldier's reasonable request. The terms of a geometric series grow rapidly when the common ratio is greater than 1. Likewise, they diminish rapidly when the common ratio is between 0 and 1. In fact, they diminish so rapidly that some infinite geometric series can have a finite sum. Take note, key concept, infinite geometric series. An infinite geometric series with first term a sub 1 and common ratio such that the absolute value of the common ratio is less than 1 has a finite sum. That can be written as S equals a sub 1 over 1 minus r. An infinite geometric series with the absolute value of r being greater than or equal to 1 does not have a finite sum. And consider why it works. Recall that the sum S sub n of a finite geometric series, a sub 1 plus a sub 1 times r plus a sub 1 times r squared, etc., is, as you know, as the number of terms increases, the value of n increases. If the absolute value of r is less than 1, then r to the nth power decreases as n increases. For very large values of n, r to the nth power becomes very close to 0. If you substitute 0 for r to the nth power in the formula for the sum of a finite geometric series, you get S sub n equals a sub 1 over 1 minus r. To say that an infinite series, a sub 1 plus a sub 2 plus a sub 3 and so on, has a sum capital S, means that the sequence of partial sums, S sub 1 equals a sub 1, S sub 2 equals a sub 1 plus a sub 2, and so on, converges to a number S as n gets very large. That means the sum gets closer and closer to a certain number, S, as n increases. When an infinite series does not converge to a sum, the series diverges. An infinite geometric series with the absolute value of r being greater than or equal to 1 diverges. And a chance to show that you have got it. Does the infinite series converge or diverge? If it converges, what is the sum? A 1/2 plus 3/4 plus 9/8 plus etc. B 1/3 minus 1/9 plus 1/27 minus 1/81 plus etc. C, the series written in summation notation seen here. And D, a reasoning question, will an infinite geometric series either converge or diverge? Explain. And your lesson check questions for section 9.5.